So our system is a data-driven solution for sustainable Yarsaghumba harvesting. So our story begins even before the Yarsaghumba harvesting even starts. So at first, in the pre-season, we have readiness. In the readiness, the conservation area officer first approves the system baseline before deploying the harvesting protocols. This section contains a seasonal pricing matrix that determines permit fees for local harvesters and outsiders, a resource inventory showing the number of available medical units and APF outposts that can be deployed to protect the harvesting area and support field operations. So, and after that, we have the zone review module. In the zone review module, we analyze the environmental data to determine how much harvesting activity an area can actually sustain. It interprets habitat suitability index scores, maximum suitable and sustainable harvesting capacity, terrain characteristics such as elevation, satellite-derived environmental information. This helps to identify most of the suitable zones for harvesting while protecting sensitive areas. After that, we have the stand table. In this pre-season stage, the conservation area officer can strategically deploy medical teams and APF security posts based on the system's recommendation and predicting harvesting activity. So we can see here we are deploying medical teams and APF security posts in the map based on the sustainability mapping, which is divided into multiple zones. And after that, we log the deployment and launch the session. So after that, we have logged all the data, and we can see that in our dashboard, which is in the active season. Now we are in the active season where the harvesting actually begins, and we can see all the zones and all the medical teams. In the dashboard, we can see a real-time overview of harvesting activities. And here the conservation area officer can monitor things like active permits, royalties collected, harvester distribution across zones. This helps ensure that harvesting remains within safe ecological limits. After that, we have the permit desk. From the permit desk, the conservation area officer can issue and print permits. Before issuing a permit, the system checks factors such as available zone capacity, current occupancy levels, whether a zone is under a recovery rate. Like if we enter a name like Cosmic Regmi here, so let me just try the name, Cosmic Regmi here, and and then we collect the fee from the harvest and issue a permit. So we get a permit for the Cosmic Regmi, and we have the 829, which is the permit ID, and we can print the ticket, and in the ticket we have all the information like map, altitude, sickness advisory, so that the harvester can be safe and certain in the harvesting zone. So we can print the permit here, and after the harvester returns from the harvesting zone to returns from the harvesting zone, he can enter his 829, his ID, and the amount he collected, like 2 kg Yarsaghumba he collected, and we can verify that data. So the checkout is complete, and we can do the next checkout. So by using the estimated or collected checkout data, we can compute the different states of the zones. And here you can see that the green zone is the normal zone where harvesting is allowed. The orange zone is the ember zone where the CPUM is declining, and the red zone is a zone where harvesting has fallen down and it is destroyed. So we are not allowed to harvest in red and gray zone. And gray zone means that the zone is recovering. So this is how we have classified the zones and compute the zone state. So in the ending note, I would like to say that by combining ecological intelligence, resource planning, and real-time monitoring, the system helps conservation authorities manage Yarsaghumba harvesting sustainably while supporting local livelihoods.